I can see attendees are still rising as I'm speaking, but I'll kick things off anyway. So welcome everybody to the next talk in our Science Talk series, where we're going to learn all about how satellite imagery is being used to map and monitor the world's shallow water coral reefs. JNCC has an MOA with Vulcan, and two of our speakers today are here from Vulcan. And our MOA is to use and promote the Allen Coral Atlas to map and monitor all UK overseas territories and the shallow coral reefs in those territories by mid-2021. The Atlas complements work already underway at JNCC, which is why it was beneficial for us to enter a partnership. So that work already looks at using satellite images for mapping, monitoring habitats, and understanding the role of those habitats in the natural environment, particularly for protecting coastlines from the impacts of disasters and supporting environmental management. We'd be very interested to hear what ideas you've got for use of the Allen Coral Atlas within your own work areas in JNCC, so please be forthcoming. If those of you are listening to this and are not listening to this live, if anybody has any questions, then please get in touch with either myself or Jane Hawkridge as we're managing the partnership. Unfortunately, Jane sends her apologies and cannot be with us today. If anybody has any questions, please put them in the question tab in the GoToWebinar function, and we'll deal with questions all at the end. So no more from me. I'm now pleased to introduce Charlie and Paulina, who's going to kick us off from Vulcan and going to give us the tour of the Allen Coral Atlas and how to use it. Over to you, Paulina.
Great, thank you, Gwawr. Like Gwawr mentioned, I'm Paulina Gerstner. I'm the program manager on the Allen Coral Atlas. I've been at Vulcan about 4.5 years. Charlie, do you want to intro?
Yeah, good morning, good afternoon, everyone. Charlie Whiton, I'm the director of the Allen Coral Atlas. I've been working with Paulina on the project since the beginning, and look forward to sharing with you guys today. Thanks for giving us your time.
And thank you to Gwawr for having us. We're here to talk about the Allen Coral Atlas as part of our partnership with JNCC, like she mentioned. Today we'll discuss what the Allen Coral Atlas product is, its technical capabilities. Charlie will do a quick demo and discuss use cases. We'll give you a sneak peek at some functionality that we're working on for future products. And then we want to talk about how the Atlas tools may relate to you and your work and hear from you. So to start, just a little bit about Vulcan. So Charlie and I are both from Vulcan. It's the company of the late co-founder of Microsoft, Paul G. Allen. So he co-founded Microsoft with Bill Gates. Our philanthropic work focuses on 4 main areas. One is conservation, oceans, communities, and finally climate. So this project is part of our oceans portfolio, which also includes combating illegal fishing and protecting marine species like sharks and rays, along with saving the world's coral reefs. So to start, just a little bit of a history of mapping coral reefs and a broader picture of the status of mapped reefs to date. We've heard that Charles Darwin was apparently the first person to start mapping reefs in the early 1800s by hand, so it sounds pretty tedious and probably time and cost intensive. And in general, mapping submerged reefs habitats is very challenging and time intensive. There are many great efforts out there already, mostly on a local or regional scale. The Nature Conservancy, for example, has done a lot of mapping in the Caribbean, and the Living Oceans Foundation has done a lot of their own as well. There's also a lot of, or several high-income countries that can afford to pay for their own mapping and have therefore pretty great maps of their territorial coastal reefs. But unfortunately, no one has reached global coverage to date. There have been efforts by the UNEP WCMC to do global reef maps long ago, but they have not been updated. So given this overall poor state of global reef mapping, the idea behind the creation of the Atlas was that having a more accurate baseline would allow for better conservation planning, coral reef restoration, and management. So the idea of the Atlas came about. So in developing this idea, we went out and talked to a lot of the people doing this marine conservation work and asked them what they were currently using. And a lot of the people just said, I use Google Earth, I use the Google Maps satellite view or something like that. So on the left here is Turks and Caicos, which might look familiar to some of you. So unfortunately, Google they have some great products, but unfortunately their focus is terrestrial. So it's really not their bread and butter to work out the issues of marine satellite kind of piecing together, which is where we felt like was our first challenge to come in and provide this product to people doing marine conservation. So the image on the right, as I will get a little bit deeper into, is the first challenge that we took on, which is the seamless satellite image of the world's coral reefs. So in detailing this problem of inadequate or not globally comparable coral reef maps, Vulcan's founder, Paul Allen, asked us, can this problem be solved? And we knew it could be solved, but we wouldn't be able to do it ourselves, so we had to find the right partners. So we pulled together this team of experts. It all started with Planet, the satellite imagery provider on the left there. And then the satellite imagery is handed off to Greg Asner and the team at Arizona State University, who who process that imagery. The field engagement team at the National Geographic Society lead outreach and field data gathering to provide as inputs to the mapping. And then it's handed over to University of Queensland, who use the imagery and field data to create the maps. And finally, Vulcan, where we are from, we provide overarching project leadership and display of the public-facing website. So to go a little bit more into the technical details of how the maps are made, like I said, it all starts with the satellite imagery. So it's 3.7 meter images from Planet that are taken daily. They have these nano satellites that are about the size of a shoebox, over 100 of them that are constantly orbiting. So it gives you a lot of options to choose from in terms of images, so you can get the best available to seam together. Then Arizona State University takes that imagery and take out all the noise, so clouds, reflection on the water surface, and then calculate the depth, which is a critical component to the mapping capability. Like I mentioned, National Geographic is in charge of the field data. So sometimes they work with people in the field to gather new data, and other times, especially lately in time of coronavirus when we can't travel as much, National Geographic Society has been working with partners around the world who have their own existing data sets that are most often georeferenced photo transects that provide to the mapping team. So then all of these components are thrown together to calibrate the automation, which happens at University of Queensland, and essentially it spits out the benthic and geomorphic maps of the world's coral reefs. So we take all of that, we put it on the publicly available website, allencoralatlas.org, which you can go check out today. It's free and open. And our intent is that it's used for conservation, restoration, and protection. So our goal from the beginning was to map the entire world with a consistent method so that you can compare apples to apples. You can look at how much coral is in Hawaii versus how much is in French Polynesia versus in the Caribbean, and really be consistent. So we began with these 6 small sites, the circles you see in the middle. And these 6 sites were chosen because they're geographically very different. We also had varying levels of field data and different types of reefs, so fringing reef, atolls, etc. From there, we scaled that method to larger locations. So we started with the Central Great Barrier Reef because it was pretty well known and nearby to the University of Queensland. They were able to go get a lot of their own field data. And then further, we continue getting larger and more complex. We mapped the Southwest Pacific, so that includes Fiji, Vanuatu, now New Caledonia, that area. Then next was West Micronesia, and then the Northern Caribbean and Bahamas, East Africa, and most recently, the Hawaiian Islands and the West Indian Ocean. So Hawaii, of course, and the West Indian Ocean includes Mauritius, Seychelles, Comores, Reunion, and that kind of geography. Next, we will map the Andaman Sea and Timor Sea regions, so getting kind of into the Southeast Asia and north of Australia area. But our goal, and we fully intend on mapping the whole world by mid-2021. We're picking up steam and doing larger and faster regions. Unfortunately, coronavirus did throw a wrench into the ordering that we had planned. Mostly in terms of field data, we had planned on gathering more of our own, but we've had to put that on halt. But this is, I guess, just a call out for those of you who may have access to people who are still in the field or have existing field data that either is geo-referenced transects or photo quadrats. We are still actively looking for people in these geographies that we have not mapped yet to work with us. So with that, I'm going to hand it off to Charlie to show you what we've done and how to use the tool. See if we can figure out the technology.
Thanks, Paulina. Yeah, we'll do the control swap on the GoToMeeting here.
Should have swapped it now. If you can show your screen.
Yep. Can everybody see the atlas?
Not
yet.
Not yet. Okay. Still no?
Not yet.
Still.
How about that? No. Any luck? No. No. Let's see. Not showing the PowerPoint?
Nope, not seeing it.
You're just seeing me so far?
Yeah.
Okay. I'm just trying different options in the show. Any luck? No. Man. Nothing so far? No. Trying to think of a different way to do this. I don't know. I guess we could give control back to Paulina,
Yep.
or yeah.
You put it back to Paulina. Yeah. What?
Okay. Charlie, do you want me to walk through the screen and you can kind of direct me?
Sure. That sounds great. Yeah. Let's see if we can make it work on your end. Sorry, everybody. So we're looking at your PowerPoint now, I think, Paulina. Do you want to switch to a browser? There we go. Great.
Okay.
Perfect. Okay. Cool. So I can see it. Hopefully everybody else can see it as well. We're looking at.
Yeah.
Okay. Great. Thank you. All right. So the introduction that Paulina gave you to the historical, how the maps are built, how the satellite imagery is collected, how we bring it together and put it on the Allen Coral Atlas platform. So sort of fast forward, I guess, to today, where, as Paulina mentioned, there are a whole bunch of regions. We think we've got about 40% of the globe mapped at this point, in the shallow water coral reefs between sort of 30 degrees north and 30 degrees south of the equator, to a depth of about 10 meters. The planet imagery, as she said, is constantly being shot every day. So we get a global visual mosaic that is super clean, no clouds, no reflection off the water, the same tide state, so low tide in all cases. So that is for display, and that's a little bit of what you're seeing now. we'll zoom in on this and I'll give you a chance to really look at it. The other thing that we do with Planet is gather data, satellite imagery that is much more current right before we do a map of an area. So so again, as clean as possible, as recent as possible, stitching those seams together with as few clouds as possible, atmospheric correction, so that ultimately what happens is we give that analytic imagery over to the mapping team, and their automation process can see through the water column as much as possible, so that they can distinguish seagrass from coral, from sand, and then we draw sort of vector images around it, and then calibrate how much of that habitat there is, and a quantification of that. So so that's the zoomed out perspective, just to sort of renew your understanding of what we're looking at here. So if Paulina, if you don't mind, if you could zoom in on, say, the Turks and Caicos, please, or we can also do Grand Cayman, but whichever one. I think yeah, there we go. Cool. Thank you. That's great. So as you can see, and if you recall the image that Paulina showed you, Google versus the Allen Coral Atlas, our terrestrial imagery is not bad. Theirs is incredible, of land, but our focus is on the water, right? So what we want to do is we want to be as seamless as possible, as low reflection as possible, so that whether you have the map or not, let's say you're having a discussion with a local marine managed area and some of the stakeholders of that area, you could use some of this imagery to sort of level set everyone's expectations on where the habitat is, and exactly what you're going to talk about when you're talking about potentially protecting or working on restoration for an area. So as she zooms in here, you can start to see more and more of the distinction of the habitat. And it's like I said, these could be 2 or 3 satellite images stitched together, but the seam is as clean as we can possibly make it, so that when you go to look at a map, which we'll show you here in a second, there's not a disconnect or a sort of a jarred connection between those 2 seams. So what we could do now is, yeah, Paulina, if you don't mind, if you want to turn on the benthic map, and then, yeah, if you wouldn't mind expanding that, that'd be great. So here in a second, the vectors will start to fill in on this area, and we'll start to see what the mappers have determined are the different sort of areas, mapped areas around this section of the Turks and Caicos. There it is. So as you saw it pop in there, and you can, and then sort of adjust your sort of your comparison from the visual on the left to the sort of the breakdown, the legend breakdown on the right hand side. That predominant yellow color is sand. Further, the sort of the coral color, or sort of that salmon color, is coral and or algae. You can see some green in there, some of that dark green. We determine that to be either rock or seagrass, and then rubble is mixed in there. So that's visual. That's super helpful. Paulina, if you can, it's going to force you to sign in, but if you don't mind drawing an AOI around this area, and maybe don't go too big, so it's so it calculates for us. So now what we're going to do, we're going to hold our breath, sort of demo mode a little bit. Hopefully it works as quickly as possible. What she's going to do is she's going to draw a small area of interest around this section of this reef area. Perfect. Thank you. So what we've got here is we've drawn just a section around this part of the TCI. What it's calculated for us is the square kilometers, as well as the percentage of the area that she selected. So you can see in the benthic classes there, the coral algae makes up for about 7.5% of that selected area. just a little less than half a square kilometer. Predominantly, it looks like it is, it's sand and rock, 38 and 37% respectively. So if you imagine a use case here of you're thinking about doing a marine protected area, say in this polygon here, and there's some debate over, well, are we protecting the right habitat? Is it mostly coral, or is it sand because we're going to do it for we're going to do some restoration work there? So by drawing this area and then looking at the calculation of the habitat, you figured out what are we focusing our efforts in the right places, or should we move it? So in this case, and Paulina, you don't have to do this, but we might decide actually we're going to move it to the east by, say, a square kilometer, because it looks like there's a lot more coral out in that area. And if that's your focus of protection, you might do that. So if you wanted to extend further, on the second tab of this dialogue that Pauline is showing, the download data dialogue, what you have the opportunity to do is download these data to your local machine. I'll caution you here, the download data set is enormous, meaning like potentially gigabytes of data. So make sure that you like the area of interest that you've selected before you do the download. What it'll do is it will tell you, will notify you when it's ready, and then which could take some time, and you'll get a notification by email that the download is ready, and then you can download it at that point. Strong internet connection, probably start it before you go to bed, and then in the morning it should be ready for you. So I say that just because some of the imagery in particular, it's enormous, but it's super clear, and then you pull it into your GIS product after the fact and do deeper analysis than you would be able to do in the web platform, or combine it with other data that you have in your GIS setup. So like I said, maybe you have fisheries data or existing MPA boundaries. It could be any number, maybe something coastal that you want to converge with. So you've got our data in the water, and you've got the coastal data in your GIS product. So that's a quick, fairly rapid, like Paulina said before, the platform is wide open, totally free. In a lot of cases, you don't have to register at all if you just want to sort of pan around and look at the areas that you're interested in. There will be more and more data mapped between now and the middle of 2021. So if your area is not mapped yet, count on it being done so over the next year. And then if you sign up for the newsletter from the homepage, we do newsletter notifications that we've updated and mapped new areas, so you would get notifications that way as well. So let's see. I think that that's a pretty solid demo of the platform as it exists today. Like I said, please play around with it, experiment with it. We're actually refreshing the website today or tomorrow, so you will see a little bit of a sort of an update of the way that the platform works, which hopefully is even more usable than it is as it stands. So great. Okay. Well, what I'll do is we'll switch gears back to the presentation. And then I'll talk you through what the future holds for the Atlas. And again, sorry for the tech difficulties, but it's easier than having flown halfway around the world to see this presentation. I can guarantee that. So Paulina is going to roll into where we're going to start talking about the future, which is monitoring these reefs. Thanks, Paulina. That's great. So, what we're showing here is we talked about mapping. There's also monitoring for the coral. If you can imagine trying to see bleaching from space is literally what we're trying to do. Like on the surface, it's just a ridiculous proposition. Even as bright as bleaching can be, seeing it maybe say 3-5 meters underneath the water, unless the water is crystal clear and the bleaching is at its brightest, still a big challenge. And it would also need to be at a pretty large area. Despite the challenge, we've done a couple of trials on the GBR bleaching that happened, when was that, almost a year ago, and then the Hawaii bleaching that happened shortly thereafter. And it looks like if the brightening is in excess of 8% brighter than a pixel's color previously, we can detect it. And what we would do is we would show that to you on this top image. That's a super high altitude sort of heat map of where some of the brightening or the bleaching had happened in larger or smaller scales. And if you zoomed in the lower area, you'd see where we detected a changed pixel color, a brighter pixel color, and then you'd be able to focus your efforts on, okay, now we know exactly where the predominant bleaching happened. So perhaps we would consider decreasing fishing or tourism temporarily. Longer term, do a marine protected area around that brightened or bleached area, so that you'd lend to potential recovery of the coral. So that's the bleaching side of things. And we're looking to get that Hawaii bleaching product on before the end of this year as sort of a proof of concept, and everybody would be able to look at that. The extension, or sort of the companion product to bleaching, is turbidity, which maybe some of you are a little bit more focused on than bleaching. This is obviously a more persistent situation in a lot of areas where the turbidity levels are, I hesitate to say stable, but a little bit more mappable, which is what we would do in this product. So if you can see, this is on the east coast of Oahu, and in the red areas, we've detected to be denser, turbid areas. Excuse me. So if you think of if some of you have seen the Coral Reef Watch bleaching predictors, which we also show on our platform. I should have showed you that a minute ago. If we have some time, maybe we'll look at that at the end. You're showing more turbid areas here. So again, like sort of how to plan your efforts on working around more turbid, a more turbid situation. So, okay, so then let's see, I remember, yeah. So the users that we focused building the atlas on, we focused on decision makers, scientists, and local community members. If we grouped these folks together and then thought about their use cases, how they're doing their work today, and how the atlas might help them do their work in the future once they have maps and monitoring, that's how we predicted it. So for the decision maker, what we thought about was these folks and maybe the technical people that they're working with would need analytics for, say, a countrywide effort. So what is the total quantification of coral in, like in this example, we're looking at Fiji. If we're looking to protect 30% of the coral reef area by 2030, where exactly would we focus those efforts? It looks like the atlas has done a map, so we don't have to go out and do a transect of a great deal of Fiji in order to calibrate where our 30% efforts would go. So regional statistics, broad spatial planning. We're working already with Vanuatu and Mozambique on efforts like this. Big countrywide marine action plans where it's an entire coastline, say 1,800 square kilometers. And so where is that 30% that we want to focus our efforts on? The next customer are the scientists. So they may be thinking about recovery or restoration. So a much more focused effort on, like, where is a good area for us to potentially do restoration work? Or if we know that bleaching had occurred, could we reduce tourism and fishing in a specific area that wouldn't upset a great deal of people, but would focus efforts on that recovery or that restoration. So, and then they could also be the people who are gathering data for a proposal for those decision makers who might be trying to engage with a policy effort. And so the third customer, the last customer, would be the local marine managed areas, the folks in the communities that are most directly affected by some sort of a protected area or a marine spatial plan. So you can imagine a community meeting. We've heard stories like this where somebody gets up in front of a whiteboard and draws, this is our reef and this is where most of the coral is. And people start debating, well, that's not my experience, or that's not the way that I saw it the last time I was out fishing. In this case, you throw up a satellite image and you throw up a map, and now you're level set, and everybody can sort of start the conversation from the same that same foundational aspect. So reducing sort of the debate over where the habitat is, how much of it there is, providing data for these stakeholder meetings, coordinating sort of a feedback loop based on these data. And then this last bullet is sort of something interesting where we didn't even know there was a reef out there, actually, because it's you know, in an area that's maybe not safe to be boating or transecting. It looks like there's something in the satellite image that makes it worth our focus. So those are the three customers. So that helps us either reach out and make sure that we're focused on the right area or sort of the right features. Downloading data, for example, was a big sort of mystery to us. Are we giving the right data to people? Is it in the right file format? Is it too big? How do we notify people? And then how do they then use it in their GIS products? Are we doing the right things? So it's very informative. We'll run through a couple of sort of specific use cases, which is kind of interesting. Sri Lanka, the Kayankurney Reef, which is off the east coast of Sri Lanka, it was a little bit unclear exactly where the habitat was. It had been designated as a marine protected area, which is fantastic. But with the Allen Coral Atlas, the map that we did is a proof of concept there. And then a lot of the local effort by an NGO, the Blue Resources Trust, folks that we've been working with there, they were able to elevate that marine protected area to a national park, which was a great story, I thought. Let's see, the next one is right, Vanuatu. The Vanuatu folks were looking to do a more broad scale protected plan, a countrywide marine spatial plan. So when we did the Southwest Pacific, that was Fiji, Vanuatu, New Caledonia, Tonga, Samoa. I think I'm forgetting something. So we were able to provide data for that marine spatial plan. We recently actually improved our depth data, which helped the mapping team at the University of Queensland improve the accuracy of their maps. A pretty significant degree. Actually, we managed to capture an additional 4,000 square kilometers of spatial habitat into those maps. So Vanuatu would have gotten even more accurately improved maps, and that's an effort that would be ongoing for the Atlas. We would continue as tech improves, as particularly satellite tech improves, which Planet is heavily invested in doing on an ongoing basis. We would be able to benefit from that improved data. And then the last one is Fiji. So if you think about that, the decision maker user that I talked about, we talked to the Ministry of Environment and the Ministry of Fisheries about how they might use the data. They're working on a 30% protection situation that would get under management by 2030. They need maps. And so if you can imagine trying to map Fiji, it's huge. And if you try to do it manually, actually putting divers in the water, it's incredibly expensive. It takes, months or longer to get it done. And then a lot of it is extrapolation, right? So, a regional map that's done at a glance would be a huge benefit to an effort like this. So I think we close out on a. Oh, sorry, I jumped ahead, but super zoomed out, very, very high level. We're working with ICRI and GCRMN on global monitoring efforts, establishing targets and indicators for the Convention on Biological Diversity for their reporting. So if you can imagine massive, say, Indonesia trying to do a massive spatial plan or protection plan, they would need a global extent. So what's the what of all of Indonesia are we targeting here, and would need a full reef extent, which we're working on now, and looking at releasing that data. So yeah, so let's see. So the last one that I like to finish on here is a user story. A user from Myanmar who we look forward to getting the maps done over the next couple of quarters, talking about how they have just no data whatsoever for their reefs. So this would fill that massive information gap for them and help provide a solid marine spatial plan for them. So that is our presentation. I'm not sure if I'm over time or under time, but hopefully I've left time for questions. I think I see the chat light going. Looks like Gwawr and team have asked for questions. So please drop your questions in the chat or the questions feature. I think there's one or the other, and we're happy to address them. Thank you very much.
Thank you, Paulina, and thank you, Charlie, for a very, very interesting presentation. And I'll hand over to Adam and Charlie to ask you any questions if there are any.
Hi there. Yeah, I just want to reiterate, thank you for that. That was super interesting. I've already seen quite a few questions come through, so I think we best crack on. Okay. So the first question we got through, and do forgive me if any of these have already been answered because I've been dealing with the technical side. So the first question is, are benthic habitat maps available for different dates, which could then be used to detect change and quantify, for example, loss of coral or seagrass habitat?
Yeah, it's a good question. The short answer is no. It sounds dramatic, but we're sort of racing to get a baseline map done of the entire globe by next year. It's a massive effort, like all software projects, much bigger than we expected. So setting that baseline is our first priority. There is the possibility that that once we feel that the accuracy level is high enough, that we would be able to do sort of a version 1, version 2, or 2019, 2020 map, whether geomorphic or benthic. But at this point, that's not within scope.
Right. Thank you very much. The next one is, I understand depth is derived from the RBG bands using a band ratio algorithm, and that this is then verified using field data. What level of accuracy is achieved?
That sounds like a Gwawr question. I think that's a plant.
I don't have that information to hand. That will probably, be from Greg Asner's team, who's created the satellite data mosaics that's got into the mapping with the University of Queensland. Right. So
sorry,
I guess the question could be, would you publish that data, that information in the quality information flag for the project?
We could, and sorry, I was joking. I meant that you had asked the question, but so you're right. So the spectrum is very limited. It's a 4-band satellite, or they are 4-band satellites. and the near infrared is not of use because it's underwater. So between the green and the blue is really what we're down to, and distinguishing those is what we're left with in determining habitat. I would add though that the mapping team also works with depth in terms of doing object-based classification. They're also able to do wave modeling, and so there's actually more determining factors in figuring out what is what underneath the water than you would expect. It's not just the satellite imagery. So that's pretty useful. Sorry, and I think that actually the main thrust of the question was, is it field verified? So we work with lots of in-country teams to get the data to calibrate the rule sets that the maps are built from, but also to validate what the outgoing map actually has produced. We do, we're not publishing the calibration validation data yet. That's a consideration. There's credit to the folks who are providing the data, but in a lot of cases, the data is openly available. We could make it available if you wanted. I don't know, Paulina, did you want to add something to that?
I think that the other question I heard in there was what's the confidence level or accuracy, and the answer is that it really varies. Obviously, you know, point to point and also region versus region. It kind of based on how much input data we have to compare it to say how accurate it is to compare to that data. But I've heard, you know, from 60 to 90 depending on the area. So it really depends.
Perfect. Thank you very much. So moving on, the next question. I see coral/algae is a single habitat class, presumably because the algae within coral gives them a similar spectral signature. Can these habitats be distinguished using imagery with higher spectral resolution? Also, is it a problem from a management conservation point of view to have these two classes combined?
Wow, good questions. These are, yeah, those are solid questions. I'll start, and then Paulina, if you want to jump in. So it's correct that we just to be sort of blunt, we can't distinguish between coral and algae because again, the limited spectrum on the satellites, they look the same, more or less the same. So we do group it together to sort of coral coverage, if you will. Between the coral and the dead coral, right? The coral covered, the algae covered coral. We have heard that it can be a challenge. Like if you are trying to if you're focusing your management only on live coral cover, then we would get you started. We would tell you this is the area where the grouping, the coral and the coral/algae is, but then what we've heard is that people would then do their own transecting there to sort of determine a percentage of what is live and what is dead in that area. So it's an extrapolation exercise that we've hoped that we've sort of narrowed down to. I'm going to pause and see, Paulina, if you want to jump in.
Yeah, and again, I think the other part of the question was, have you looked at other sensors that could tell the difference? The answer is yes, although our main focus is, like Charlie mentioned earlier, finishing the globe the first time at this level, especially because we've heard that hyperspectral sensors can probably tell us the difference, and I think there have been projects that have done that either on a drone or whatnot. But the idea with the satellite imagery is that it's for the cost, it's much more reasonable to do the entire globe at such a huge scale. So as that technology, rapidly evolves, we're kind of waiting for that possibility to become a reality for us, and it's definitely something we're looking at for the future, but kind of waiting on the technology.
Excellent, thank you. So the next one is, do you provide the data via web services, e.g. WMS, as well as via download?
Wow, I'm sorry to suspect my own engineering team is on the call. Yes, that is exactly how the downloads are built. So we've built an API to be publicly exposed, but we also use the API ourselves for the download function. And it is a WMS product. So look for documentation on the API, on access to the API over the next couple of months. It'll be on the, I can't remember the exact tab that's up there, probably the science and methods or the FAQ. And it'll give you code examples, probably a Jupyter notebook of how to download the data via the API. So what's funny about it is, if you're downloading a lot of data, it sort of makes sense to use the API. If you only need one data set, then I would say don't wait for the API, just go ahead and do it now. It's the exact same end product, you're just getting it through the web interface instead.
Excellent, thank you very much. So which Caribbean, UK overseas territories have been mapped so far?
Pauline, you want to do that?
Sure. So far, in that Northern Caribbean and Bahamas region that we mentioned, the Cayman Islands and Turks and Caicos are included. But we think of our understanding of the UK overseas territories, those are only 2 so far. The British Indian Ocean Territory will be part of a region that we're working on in the near future. I think kind of early 2021, that will be out. If you have other specific places that you're wondering about, maybe send us a message or email, and we can give you a better date for that specific location. But all before summer of next year.
Excellent.
They could also get that information from me, because I think you've given us a rough timetable estimate. So you can always ask me if you wanted to know about some of the other territories as well.
Excellent, thanks both. So moving on to the next one, is there a scope at the end of the project for organisations to improve accuracy or integrate ground truthing of individual areas, or is it a global product only?
So yeah, so the rules that the University of Queensland use to automate a mapped area are definitely established by local sort of field data. So we're working with agencies in country, especially since we can't travel to get the data. It ends up, it's sort of an odd, I would say positive product of the no travel situation is that we've engaged deeply with local communities to get data, and so the maps are even more accurate. I would say that in the future, probably a little more distant future, say 2-3 years kind of thing, a V2 of the maps could happen that are even more accurate. Like Paulina was talking about, improved spectral bands from the satellite imagery certainly helps that, but also AI ML driven mapping could make them more accurate as well. So a little bit of a longer term objective, but absolutely possible.
Excellent, thank you. So I realise I'm bombarding you with questions at the moment, so I'm just going to interrupt with several comments here saying really good answers and interesting presentation and demo, and basically thank you for the talk.
Thank you.
After that little break, thanks for the presentation, super interesting. Assuming there are coral sites surrounded by white mobile sediment, is it possible to separate out bleaching from sediment movement or account for this?
Wow. I will be honest, I'm not sure. I think I would not want to just venture into an answer that I'm not clear on there. So the distinction of the brightened pixels, we're trying to be careful that we're not calling it bleaching. I think this may sort of in a roundabout way answer the question. It could be, what was the term? Mobile sediment?
White mobile sediment.
Okay, yeah. So I think what we're trying to be a little bit cautious until we have like really decent in-field verification from people on some of these initial monitored sites that we're going to do that we have detected bleaching, or no, it is actually some other sort of brightened element that caused the pixel to trigger. So yeah, so we're actually intentionally calling it brightening for sort of that cautious reason.
Excellent, thank you. You mentioned object-based approach in your answer to the question about depth derivation. What software or tool do you use to segment the imagery to create objects?
Great. I love these questions. Initially, when we started, we were using eCognition, which is a call it a manual, just sort of a human-driven, rule-based sort of determination product. But in order to do the globe, we had to automate. So Google Earth Engine is a tool that basically does the automated version of what we've done, what we were doing. Sorry, clearly the University of Queensland team were doing in eCognition. So from a JavaScript perspective, we can write rules that scan the satellite imagery and then make determinations for the vector the vector piece, if you will, for the habitat. I think I got all the question. Oh, well, there was a little bit more about the object-based, but I guess it led into the latter part of the question. Let me know if I didn't get all of it, though.
Perfect. Yeah, if the questioner wants to just confirm whether they think that's covered the question, that would be great. Perfect answer. Thank you. And we're on to our final question. So if anyone has any more, please feel free to ask before we close. So it's just a short one, this one. Where Reef is recognized, is there a level of diversity described?
Paulina, you want to tackle it?
I think the answer is no, unfortunately. So because it's 3.7 meter resolution and because we're limited to those bands that Charlie mentioned, we're not able to tell what type of coral it is. I think that's what the person is asking. But again, that could be something that we'd be able to see from the bands in like a hyperspectral sensor if that were possible in the future.
Perfect, thank you very much.
Can I add to that? I think the technology might not be there yet for that, because I think you'd need spatial resolution that's quite high, as well as high spectral resolution to be able to answer that question. So maybe some people might be able to do it with drones over small areas in the future, because the technologies you can now put on drones is rapidly evolving, but we probably won't be able to do that from space for quite a while yet, I would imagine.
Perfect. Right, we no longer have any questions coming through. I'm just going to hold on for an extra 20 seconds or so, just so that anyone furiously writing one can get it in.
I might fill the 20 seconds just really quickly. Just a quick story. The oil spill in Mauritius 3 weeks ago, 3 weeks ago, was an interesting use case for the downloaded data. What we ended up doing was we were able to download the maps of Mauritius, that east coast area where the ship grounded. And then a company called Ursa, who work with ICEYE satellites, which are able to do SAR detection, so sort of surface disturbance detection. They were able to detect where the oil spill had traveled day to day. And then so in a GIS product, we took the map data and the SAR data and were able to combine it actually with the SkySat data that Planet provide, and make really interesting, usable information for some of the groundwork, the recovery effort that was happening there. So just as a strong example of why downloading and sort of your own GIS mashup could be super useful.
Brilliant, thank you, Charlie. We have no further questions popping in. So Gwawr, do you have anything else to add?
No, so the last thing for me to do is to thank both our speakers today for taking time out of the day to come in to speak to us. So thank you, Paulina and Charlie. Also thank the JNCC Science Team's talk for organising the tech behind the scenes and making sure everything goes smoothly. And lots of questions, so thank you to everybody for coming and listening and asking lots of interesting questions as well. So I'll close this webinar off on a high, I think. So thanks, everybody.
Thank you, everyone.
Thank you.
Bye-bye.
Thank you.